Okay. Hello everyone. Welcome to our machine learning workshop with ML.net. This workshop will be recorded and will be posted on our YouTube channel just in case you want to reference it back later and for those people who couldn't make it. We have Denis here with us today, who is going to be teaching us machine learning. We really thank you for coming here on a Saturday and, taking your time. But the floor is all yours. Yeah, thank you once again.
Hello, everyone. My name is Denis Kondratev. I'm a software engineer with over 17 years of experience in the field. And I spent a considerable part of my career developing various security systems. But for the past 5 years, I've been immersed in the world of game development. And I believe that machine learning has the potential to help us create better games and not only games, but also better applications. Machine learning is not just about being on the cutting edge of technology, it's about understanding the tools that we are shaping our world today. We live in the age of data. Every second we're generating an immense amount of it, and machine learning is the tool that allows us to understand this data. Moreover, there is a demand in the job market for those with ML skills. We see that this trend is starting to increase, and I believe it will continue strongly into the future. I would like to add that using machine learning is much easier than you might think. Today, we will understand that machine learning is what machine learning is and how you can easily start using it with ML.net. And let me show my presentation. Okay, great. And okay, today we'll begin with the explanation of what machine learning is and where it can be applied. Next, we will briefly turn our attention to .NET, discussing the benefits you can reap by studying and using this platform. After that, we'll introduce ML.net, a comprehensive framework that brings the power of machine learning into the .NET environment. Lastly, we'll showcase a practical demonstration of ML.net in action. Through this, you'll get to experience firsthand how ML.net can be easily utilized to address real-world machine learning challenges. Machine learning is a powerful subset of artificial intelligence. In simple terms, it's about training machines to learn from experience and make decisions or predictions based on the learned knowledge without the need for explicit programming. The process of machine learning involves several key steps. Starting with data input, we then prepare the data to make it suitable for ML model. The model is then trained on this data, evaluated for accuracy and performance, and finally deployed to perform particular tasks. Data is the key to machine learning. It is the information that feeds our models, and the quality and quantity of these data can significantly influence the model's performance and accuracy. Therefore, it's crucial to ensure that we're using high quality, relevant data when training our ML models. And machine learning can be broadly classified into 4 categories: supervised, unsupervised, semi-supervised, and reinforcement learning. Understanding each type will help you in the future to understand exactly what you need. Let's talk about each type in more detail. Supervised learning is one of the most common types of machine learning. It involves training a model using a data set where the correct answers or labels are known. The model learns from these data, understanding the relationship between the inputs and the outputs. Once trained, the model can be used to predict the outputs for new unseen data. This is particularly useful in a variety of real-world applications. For instance, in email spam classification, a model can be trained on emails that have already been labeled as spam or not spam. It learns from these labels to classify new emails correctly. Similarly, in credit card fraud detection, models can be trained to identify fraudulent transactions based on past transaction data. Image recognition is another great example of supervised learning. Models can be trained to recognize and label different objects in images based on previously labeled image data. Unsupervised learning is a fascinating type of machine learning. Unlike supervised learning, the model is not provided with any correct answers or labels during the training phase. Instead, the model must discover patterns, relationships, and structures within the data all on its own. Unsupervised learning has several real-world applications. For instance, it's commonly used in customer segmentation, where businesses group customers based on various factors like purchasing behavior, demographics, and more. Anomaly detection is another important application of unsupervised learning. For example, it can be used to identify anomalous network traffic and detect potential threats in its security. Semi-supervised learning combines elements of both supervised and unsupervised learning. The model is trained on the partially labeled data set. This means that some of the data points have known outcomes or labels, while others do not. The model learns from the labeled data and applies that knowledge to make predicts for the unlabeled data. Semi-supervised learning has for utility in several applications. For example, in image classification, it's often the case when we have a small number of labeled images and a large number of unlabeled ones. In such cases, the model can learn features from the labeled images and predict new labels for the unlabeled ones. Similarly, in speech analysis, when only a small portion of speech data is transcribed, semi-supervised learning can be used to predict transcriptions for the rest of the data. Another application is in web page classification. If only some of the web pages are labeled with their categories, semi-supervised learning can help predict categories for the rest of the pages. Reinforcement learning is an unique kind of machine learning where an agent learns to make decisions based on the feedback it gets from its action. The agent interacts with an environment, takes actions, and gets reward and/or penalties. Over time, it learns to take actions that maximize the overall reward. There are many practical applications of reinforcement learning. For example, it can be used in autonomous driving. The model acting as an agent learns to drive by interacting with a simulated environment and receiving feedback based on its actions. Reinforcement learning is also frequently used in game playing. Models can be trained to play games like chess and Go. Now it's gradually coming to video games. The model learns the rule and strategy by playing the game repeatedly and learning from the outcomes. In robotics, reinforcement learning is often used to train a robot to navigate through a specific environment. The robot learns from its own mistakes and successes, gradually improving its ability to navigate effectively. And let me tell you a few words about .NET. It is a powerful tool that is free, open source, and supports the creation of a wide range of application types. This includes everything from web to mobile to traditional web-based applications and even video games. There are several reasons to consider studying and using .NET. With .NET, you're not restricted to one kind of application or platform. This means you can use .NET to create diverse applications, whether you're developing a complex web application or an immersive video game. In today's world, .NET is used widely across industries. Its support for multiple languages and strong enterprise-level application capabilities make it a popular choice for many organizations. The game industry is no exception. For example, Unity allows you to create games with C#. With the introduction of ML.NET, this platform has also opened doors for developers in the field of machine learning, providing them with tools and libraries to build ML models using their .NET skills. And before we move to the demonstration of how to use ML.NET, let's take a moment to learn a little more about this powerful framework and what it can offer us. ML.NET is a cross-platform open source machine learning framework developed by Microsoft. It is designed for .NET developers, enabling them to create custom machine learning models using familiar languages such as C# or F# without needing extensive knowledge of machine learning. It was first introduced in 2018 and has since been regularly updated and improved, making it a robust and a comprehensive tool for machine learning tasks. ML.NET isn't just for experienced data scientists. It's also aimed at .NET developers who are new to machine learning. Even beginners can start building ML models with relative ease. Furthermore, while ML.NET allows developers to craft their own machine learning models from scratch, it also supports the use of pre-built models. This means that if there is an existing model that fits your needs, you can incorporate it into your project with ease. This flexibility makes ML.NET a powerful tool for developers looking to leverage machine learning in their application. ML.NET is built with .NET developers in mind. It integrates smoothly with the .NET ecosystem. It empowers you to leverage your existing .NET knowledge, skill, code, and libraries. This means you can transition into machine learning more easily using tools and languages you are already familiar with. With ML.NET, creating custom machine learning models is easier than ever. The platform provides tools like Model Builder, which offers a user-friendly interface. These tools utilize the power of automated machine learning or AutoML. This is a cutting-edge technology that automates the model building process, allowing you to focus on what you do best, developing great applications. With AutoML, all you need to do is load your data. From this, AutoML takes care of the rest, automatically selecting the best performing models for your specific machine learning scenario. This makes ML.NET not only a powerful tool, but also a convenient and efficient one for .NET developers looking to incorporate machine learning into their application. One of the key strengths of ML.NET is its extensibility. It's designed to be a platform which can work in tandem with other popular machine learning frameworks. This includes TensorFlow, Onyx, Infer.NET, and others. The benefit on these is access to a wider range of machine learning scenarios. You're not limited to the capabilities inherent in ML.NET alone. By integrating with these other frameworks, you can tackle more complex scenarios like object detection. ML.NET not only offers ease of use, but it also delivers in terms of performance and accuracy. To illustrate this, consider a benchmark example where a 9 GB Amazon review dataset was used to train a sentiment analysis model. ML.NET achieved a 95% accuracy, while other popular machine learning frameworks couldn't even process the entire dataset due to memory errors. But that's not all. When training was conducted on just 10% of the dataset, in order to allow other frameworks to complete the training process, ML.NET still demonstrated superior speed and accuracy. This high performance is not limited to sentiment analysis. Similar results have been found in other machine learning scenarios, such as click-through rate prediction and flight delay predictions. This is a testament to the high performance capabilities of ML.NET. And let's take a quick overview of getting started with ML.NET in your .NET application. So I have a simple console application. In this example, I'll show you how to create it and train a model which does sentiment analysis. And for that, let me switch the screen. Just give me just a moment. Okay. Mhm. Yeah. Okay. It's the screen, and it is Visual Studio, what is made by Microsoft, and it that programs offers you easily start using machine learning in any of your project, whether it is a web application or web API or desktop application or mobile application. It is just a simple console application, and I choose it just to show you how it is easy to start using machine learning in your projects. In your projects, I have prepared some simple data set uh, which I will use. It is it is a pretty simple data set that contains some commands and a label for it. 0 means that it is negative command, and 1 means that it is positive command. And with that or similar data set, uh, we can then predict other commands and automatically sort them, for example. But of course, it is not a real data set, because it is pretty short data, just for that presentation, because training a model with a real data set can take hours, actually. And of course, we don't have so much time. And let's start. First of all, we have to add a ML model to our project, and it is easy to do. In Visual Studio, I just right click on the project and add machine learning model. I'll name it just model. Okay, and it is now we see the window of model builder. It is a powerful instrument, a powerful tool that helps you create and train models without extensive knowledge of machine learning. All you need to know is what kind of data you have and how to prepare that data for training, for model training. And for our case, I'll choose data classification, because we will evaluate the comments. And then we have to choose environment where we will train our model, and I choose my local CPU. And if you already have some project with a database, for example, it can be like website or web application, and you have a database with some information, you strictly can use your SQL server. But of course, you can prepare your data in the file, and I use file for that. And I choose the file with the data set that I've already shown. Okay, in this file, we have two columns. First column contains comments, and the second one contains labels for that comments. As I said, 0 means negative, negative comment, and 1 means a positive one. And I want my model to predict the column, to predict labels, of course. And in this case, model builder will use first column, add source data to train our model predicting second column. Okay, and as I said, real data training model on real data set can take hours, but in our case, it's just small data set for that presentation, and I think 15 seconds will be enough for us. And now model builder, it uses different types of models and looking for the best model for our scenario. And yeah, that's enough. It is ready. And on the next step, we can evaluate. We can evaluate our model. For example, if we use that command, good case, excellent value, we will predict it. And as we see, the model evaluated as a positive comment. Okay, and the next step, we see that model builder offers just several options. For example, we can just copy a code snippet of how to use that model, or we just can create our web API from scratch with the existing model. In that case, I already has my empty console application, and I just I'll copy that code snippet for my future application. Okay, and it will take just a few moments to write a simple console application that will evaluate our comments. Okay, we will have different comments, and we will take it just from console until it is not empty. Okay, just read line from console, and the application will evaluate until while the comment is not empty, and then I'll copy that snippet and use it there. Just the column first would contains our command, and we just get a result, and we put to the console the result. of evaluation. Predicted label. And as I said, in our data set, we had two labels, 1 and 0. And if it is 1, it will be a positive comment. Otherwise, it will be a negative one. Okay, and I write just a simple program and just check it out. There is a simple console application and it waits a comment for a comment like yeah, and for example, it is good thing, and it evaluates that. It evaluates that as a positive comment and something maybe. It is. You shouldn't expect that that model would be very accurate because we have a very small data set. Of course, it looks bad. Yeah, and it's negative comment. Yeah, and actually, that's all that I wanted to show you in that workshop. And I just wanted to show you how to easily nowadays start using machine learning in your projects, because you even don't have extensive knowledge of machine learning nowadays. You just have to know how to work with data. You just have to understand your data. And actually nowadays on different hackathons, it is available when hackers use machine learning in their projects. And I think it at least worth to try to using it, you know. And thank you very much.
Thank you. It was a very lovely workshop, and as you said, machine learning, it's very useful. It was a very lovely workshop, and I could say that we all enjoyed. We do have some questions in the chat, if you're okay responding to them, such as Dean talking about if you could maybe give like a recommended roadmap and how he should try to learn neural networks himself.
Mm-hmm. I have started deep learning. Can you please give me a recommendation roadmap of the deep learning models to learn? Actually, it depends on what framework you use. Because, for example, in my case, I'm a game developer, and we use machine learning for detecting cheaters in our online games. And for me, for example, we use, as I said, ML.net, and I don't have any deep knowledge of machine learning because I'm a game developer, and the main idea of that as a game developer, I understand the data that I can receive from gameplay and from cheaters and from normal good players, and prepare for machine learning. And actually, nowadays, in my case at least, the model builder does the rest of the things for us. It looks for better models for us, and so on. Yeah, and if you want to be data analysis, or like if you want dive into machine learning deeper and want be not who that just use that machine learning, but who creates that for other developers. In that case, unfortunately, I can't help you because I'm just a game developer who started using machine learning, and also should I try to learn how to write and neural networks might well to get better understanding. And actually, it is controversial question, because actually I did it. Yeah, I write some custom neural networks to better understand how it works, and I did it just for fun. But in some case, yeah, it depends on what is your goals, or what you have to do. Because as I said, nowadays there is no need to so deep understand machine learning for using that. Could you recommend machine learning resources? Yeah, I think I should have prepared that. But what mostly what I used, I use for game development Unity, and it based partially on .NET. That's why I use ML.NET. And actually, on the official Microsoft website, official Microsoft website contains a very good articles and tutorials and documentations for that, to use ML.NET. And unfortunately, I have no information about other frameworks. I have no deep information about other frameworks. Yeah, but I think I look for that information in the future. Yeah, but if you want to become a .NET developer, because with .NET, for example, if you want to create a web application, you can use it. If you want to create if you write some servers, you can use it. If you want to make mobile application, you can use it. And in all that range of different applications, you can use ML.NET easily without extensive knowledge of machine learning. Just with understanding your data, for example. For example, if you have some online store, you can analyze customer behavior on your store with machine learning, and maybe you can find some problems on your store, why some people don't buy some items, products. Yeah. Okay.
Thank you. Yeah. if y'all have any questions, then I know that Dennis is on the Discord. So maybe if you're okay with maybe them DMing you on
No problem.
Discord, then you can do so, or you can do in the chat right now. But other than that, it was a great workshop, and I hope y'all even enjoyed the demo. Thank you for that. That maybe explained some of the concepts better. And yeah, so bye y'all, and the
Yeah.
workshop.
Bye.
Bye.
Bye. Thank you.